All right, prep your 5-3 notes for geometry on Friday, February 26th. Make sure the date is on your paper, your first and last name. Get settled in for a lesson, and I'm going to discuss and go through all the 5-3 notes and hopefully help you better understand the work that you're going to have to do today. First things first, to define a couple of vocabulary terms. I found them in our book too, because this was not something that, these are review terms. Rigid motion was on page 176 in chapter 4, a transformation that preserves angle, measures, and length. Jot down the page. I found that first. Rigid motion, a transformation that preserves angle, measures, and length. And again, that was from page 176. Put it out in the margin. You're going to possibly want to look this up. After the end of the lesson, I'm going to suggest a few places during the notes that you go and find things in your textbook, so when the lesson is over, you can get your book and go to the places that I suggest. If you've already copied your rigid motion definition, a transformation that preserves angle, measure, and length. From page 200, our idea of congruent figures. Figures that have the same shape, size, and shape. Figures that have the same size and shape. I'm going to make a note on there too. All angle measures are the same. Or, I'm sorry, corresponding angle measures are the same. And side measures. Let's use the congruent symbol. Congruent symbol. Figures that have the same size and shape, congruent figures. In a rigid motion, that movement that we take figures through, our transformations, our translations, rotations, reflections. So we're looking at triangle congruence, like how can we prove, like give enough evidence that two triangles are congruent. And what we've dealt with so far is knowing that triangles were congruent. We've matched up and paired up sides and angles that were the same. But we knew that the triangles were congruent that we started with. Now, in the cases that we're going to deal with our triangle congruence theorems, because there's going to be many of them, today's first one is SAS. But what we're dealing with is not knowing that two triangles are congruent, and we want to try to prove or give evidence that they are. And SAS is a theorem that gives us permission to say that two triangles are congruent. So first of all, before I get into some extra examples and notes here, the theorem says if two sides, that's the side and the side on the outside, if two sides in the included angle of one triangle are congruent. So if two sides in the included angle, and now this included angle, I like the idea of between. Included means it's between the two sides that are already known to be congruent. So if you look at the drawing over here, what that means, if two sides in the included angle of one triangle are congruent to two sides in the included angle of a second triangle, then the two triangles are congruent. So we've got a pair of sides. So they talk about that over here. If AB is congruent to DE, I just showed those markings there. Then they talk about how angle A, if angle A is congruent to angle D. There's your angle. Angle A is congruent to angle D. And then we go back and talk about sides. AC is congruent to DF. And so this is a side pair, an angle pair, and a side pair. There's your SAS. And the included angle, see how it's between? Angle A is between those sides that we knew were congruent to each other from each drawing. So side angle, side congruence, we have to look for that relationship. That's going to be our focus. All we want to do throughout this lesson and our work today is to look for this side angle, side congruence idea. Can we match it up? Because if we can find it, then we can say that two triangles are congruent. So I have a couple examples ready. Like this one on the left, this one on the right is kind of, you can't see it very well. I'm going to redraw it when we get to it. But this one on the left here, if you could sketch this. And I started out my sketch by drawing a parallelogram. X, W, Y, Z. I'm sorry, X, W, Z, Y. And then I drew a diagonal across that parallelogram. And I have two sets of markings. I have a pair of side lengths there that are marked, and then I have a pair of angles here that are marked, those congruence markings we're going to talk about and see if we can give an example of side angle side. That's our question. Once you have the drawing down, I want to look at the things that we have marked here. In the drawing, I have side length congruence. I have YZ, segment YZ, congruent to segment XW. I'm going to consider that to be a pair of sides that I have that are congruent. I'm collecting some evidence here. I'm just going to point out what I know. These two side lengths are congruent to each other. I also know that, now I'm going to have to name these angles because there's multiple angles here at Z, there's multiple angles at X, there's 3 actually. Angle YZX, YZX, this is the angle I'm talking about, is congruent to angle WXZ, angle WXZ. This angle here. I marked it. The drawing came with that information that those were congruent. The question is, are these two triangles congruent? If I only know these two things marked, what else can I conclude? Because right now I have a side pair and I have an angle pair. Now I want to remind you about something. Hopefully you've had enough time to get that information down. This side is shared here. XZ is shared on both of the triangles that I see. I talked about how there's a parallelogram. Then when I cut it, I turn that parallelogram into 2 triangles. So this side length, XZ, I'm going to assume it's congruent. Now, what was that? Is it the symmetric property? I think it's a symmetric property that says it is what it is. Maybe. Is it the symmetric or is it reflexive? I don't have my other notes. I'd have to look it up. But anyhow, we've come across this idea. A is A, B is B. And this is an example of when we're using it. We're going to point out that these two sides are congruent to each other because we're back to trying to prove triangle congruence. And I had an obvious pair. These sides congruent. There's one of the, I have to have a side pair, angle pair, side pair. These sides were congruent, there's one side pair. These angles were marked congruent, there's the other pair. There's the angle pair. And then I needed another side pair, and I looked and said, oh, this is shared, so I just made the statement that those were the same to prove that. Now what I'm going to do at this point is I'm going to start at the angle. I'm going to name my congruent triangles, because if I've got side angle side satisfied, that means that I've just shown or proved that the triangles are congruent. So I'm going to start and I'm going to name ZYX. ZYX is congruent to, there's my congruence markings. I put it underneath. Kind of weird, but I got this paper over here. Let's see, I started at the angle ZYX, XWZ, triangle XWZ. So I took what was marked, wrote down the congruence relationships from the markings. Then I made my last assumption about the side being shared, and I was able to prove or explain that these two triangles were congruent by side angle side. Now there's one more. I'm going to redraw it. I don't like it. Kind of looks like, well, that's not very straight. There, something to that effect. There we go. Wow, terrible drawing. P S Q T. So I'm going to give you some information about this awful drawing. This is a perfect example of how you have to use markings and whatnot on your drawings to determine if things are congruent by proving it rather than just looking like it. So if I give you that information, so what I'm sharing with you right now is that the segment PS is congruent to the segment PT. With that information, I also want to tell you that PQ bisects angle SPT. So throwing that at you just to get you to take information that's written in words and then add it to a drawing in terms of the markings that it would produce. Now, the idea that PQ bisects this angle, the angle we're talking about is SPT here, means that this segment PQ is splitting this angle into equal parts. Now, this isn't about finding what that angle measure is. You know, if we knew one of them was, if we knew the whole thing was 100, these would each be 50. It's not like that. It's just about showing that they're congruent. And we're back to, is this an example of SAS? And let's gather some evidence to see if it is, because if it is, then we have these two triangles that are congruent to each other. So knowing that, I'm going to start out by talking about the pair of sides that I originally marked, PT, congruent to PS. Those markings were there. So there's a pair of sides for you. Then I just talked about the information we got here about the angles, and I marked those. So I wound up marking, let's see here, angle SPQ. SPQ is congruent to angle TPQ. So I am looking for, and here again, I'm going to be naming PQ as QP for this third pair. I'm going to be using that. Is it reflexive or symmetric? I'm interested. I hope somebody in class looks it up. You can jot that down. Tell me. So right there again, I have the side angle side relationship, so I can prove that the two triangles are congruent to each other. So then the last thing I'm going to do is write a congruent statement. Let's see here. I'm going to go PQT, triangle PQT is congruent to. I've gathered evidence under the side angle side theorem to show that these two triangles are congruent. Where did I start? PQS. Cool. So there's two examples that you have in your notes. Hopefully this fits nicely in your little notes section. I'm going to hold off just a second before I turn the page. All right, moving on. Now, I'm going to go through a couple of proofs that these are called. These proofs are just a formal way of gathering that evidence or information like I was talking about on the other side. I was trying to pull together side angle side. Now, again, you're going to watch me use this idea of trying to pull together this side angle side relationship based on the information that's given and what we're trying to conclude. We're trying to conclude that triangles are congruent, and on the other page you saw me informally gather up information to show that a couple of triangles are congruent. So what I'm going to do now, though, is I'm going to take what's written in terms of what's called the given, what information we know. It's just like what I gave you on the other pages where I marked drawings and talked about what I was showing you. Now, one of the statements, so we're going to pull together statements and then reasons behind our statements. And again, this is just a formal way of getting to triangle congruence. So I was starting to write out the first part of what we were given. BD is perpendicular to AC. Now, those are marked. BD is perpendicular to AC. AC is this segment here. Now, if BD is perpendicular to AC, I'm going to draw a conclusion based on that angle BDA is equal to 90 degrees. And that's the definition of perpendicular. Definition of perpendicular lines. I can also conclude that BC, angle BDC, is equal to 90 degrees. Based on the same definition. Those two lines are perpendicular. I've got 90-degree angles created right here. Now, I can say from this that angle BDA is congruent to angle BDC. Since they're both equal to 90, that's actually the transitive property. If they're both equal to 90, they must be equal to each other. We've used that transitive property. If A equals B and B equals C, then A equals C. I'm going to run out of some room here. Where's my pencil? Kind of group these things up. So I started out talking about one thing that was given. I defined it. And then the reason I'm pointing this out is because I feel like this is something that's going to give me the angle piece of side angle side. I feel like there's a pair of angles right there that I just talked about being congruent. Now, if I go back to the given, there was another piece of information that was sitting there for me, and that piece of information was that, let's see, where did it go? AD is congruent to angle A, I'm sorry, segment AD is congruent to segment CD. I'm going to write down that that information was given. Oh, there's a pair of my sides. Now, it started to mark BD, because I need to talk about BD. BD is congruent to BD. I really need this rule. Geez Louise, somebody better have it. It's either reflexive or symmetric. Put it in there. That's my other side relationship. So I pulled sides here. I pulled sides here. And that actually is my, there, let me just mark that. Side, angle, side, side, angle, side. I've actually gotten to the last step would be to say triangle. I hope yours can fit because I got a whole nother proof down here. Let's see. So the final conclusion here, I can read my given. Triangle ABD is congruent to triangle CBD, and that's by SAS. So my reasons come over here. Geez, went all the way over. Now, I'm going to slide this up. I'm going to start thinking about this next proof if you're catching up on any of the statements and reasons. So a formal way to talk about triangle congruent. After this proof, I'm going to give you some tips about a few other things to do in these notes, and then you're going to have time to start your homework. Actually, start. It's not a homework. It's classwork. Start and finish. You have today. All right, so moving on. I hope you can read your given better than I can. I'm on the struggle bus here, but I'm going to use the marks. Let's see here. JN. So the first thing in the given is JN is congruent to NM. I'm talking about this little piece right here. Let's see. What triangle congruence am I trying to get to here? I put my pencil down somewhere. There it is. Prove J and K. Ooh, okay. This triangle, because I see a bunch of triangles embedded in here. That's why I was trying to get focused on what are we talking about. MLN. MLN. Trying to prove these two triangles. Oh, I think this is going to be reasonably easy. Let's see. Start out. JN. And again, I'm going for side angle side. MN. JM congruent to MN. That's a given. I just mark those. I'm going to go on and talk about something that I noticed right away. These guys right here are vertical angles. So actually, my next reason is going to be definition of vertical angles. Because I'm trying to pull together that side angle side relationship to prove those two triangles are congruent, to pull together three pieces of evidence in terms of side length, pair of sides congruent, pair of angles congruent, another pair of sides. So now I got to name these. Angle J and K is congruent to M and L. Talked about that because those are vertical angles. Then the next piece of information I'm going to throw into my proof is this NK and NL. NK congruent to NL. That was part of the given. Now it might seem like I'm pulling together this information pretty quickly because I am. I really am. And the fact of the matter is it's going to take some thinking and analyzing for you to get to these conclusions. You're going to have to analyze the figure like I did. Decide which, what triangles am I even working with? I shaded that in. What's some things about these triangles that I already know from previous lessons? Like I saw right away that these two angles are congruent because of what they were called. And we pull that information together because we want to get to that SAS congruence. And so this is a better ending to the proof. I got all squished up there. J and K. This proof is a little more clear and concise than all the pieces I had to do in the last one. M and L. And by SAS, congruence theorem is the reason why those triangles are congruent. So I took what was given in two places, pieced together with another definition from something that I knew from earlier, and pulled together that side angle side. And again, this angle had to be included. And included meaning that it's where the congruent sides intersect. All right, last but not least, I'd like you to, in a few moments, I want you to get into your textbook. There's a few things I want you to take a look at on your own. For exercise 3 here, we went through it, exercise 1 and 2. I want you to see example 2 on page 247, and I want you to complete number 3 here in your guided notes. So don't move yet until the video is over and the sub tells you to. I want you to give an attempt to number 4. A, B, C, D, E, F is the regular hexagon. Now let me mark some things. Regular means that all the sides are equal length. All the sides are equal length. Take a look at that. Jot down some ideas there to do. Make sure you read the directions and what it is you're supposed to figure out. It's triangle congruent. Pick out 2 triangles in each of these that you could prove are congruent and do it. And then if you could come up with an argument for number 5. Number 5, I'm going to call this a bonus question. And I have a hint down here for number 5. Mark what's known from what is discussed. All the pieces. You've got parallel lines. You've got a congruent statement. And then a suggestion for what triangles to show are congruent. So I would be thrilled to see this on Monday. Anybody that wants an opportunity to explain this bonus problem could get some extra credit. Now, your classwork, which you have to take care of today, Friday the 26th, is 5.3 Practice A. Your sub will pass this out to you so you can begin working on it. It's only the front. It's 5 problems. Big thing, read the directions and make sure that in every problem that you're doing an explanation of your thinking, pulling together proof. Work efficiently. Be good. See you Monday.